Collisions. Yes, students, welcome back to our YouTube channel. This is your Raju sir. Long question, 8 marks question. ఈజీగా హ్యాపీగా ఈజీగా నేర్చేసుకుందాం. How to derive this expression for this collisions, right? Elastic collision. So I'm reading the question. What are collisions? First, you have to explain types of collisions. First, theory. Next, explain the possible types of collisions. You have to explain. Next, develop the theory of one-dimensional elastic collision. Here, asking only one-dimensional elastic collision. Before that, we have to explain the possible types of collisions. Okay, let's go to the topic. Here, next, see, here types of collisions. Here mainly two types of collisions we have. One is elastic collision, another one is inelastic collision. So let us consider collision, elastic, inelastic. Right. So what is meant by collision? So what is meant by collision? If any object have mass, it is moving with velocity v, means we can see that examples, accidents, right? So one object is moving and it is hitting another object. At that time, what happens means momentum conserved. Momentum is nothing but mass into velocity. The product of mass into velocity. Right. We are coming to the top point. Here, collision means a strong interaction between two bodies or bodies. Means one body will hit the another body, which involves in that what happens, exchange of momenta. Momenta means momentum denoted with p. It is a product of mass and velocity. Is called collisions. There are two types: elastic collision, inelastic collision. What is the main difference? Means here after hitting there is no energy loss. Means the total momentum is conserved, total energy is conserved, then the momentum is said to be elastic collision. If the momentum and kinetic energy are conserved, both momentum and kinetic energy are conserved, then the momentum is said to be elastic collision. In elastic collision, only momentum is conserved but not kinetic energy. Then such type of collisions we call it as inelastic collision. Very key points I am explaining here. Next, perfectly inelastic collision. This perfectly inelastic collision means if two bodies move together after collision. Example, if a bullet is fired to the wooden block, the bullet was struck in the wooden block and bullet both are moving together. So after collision, they join together and move. Such type of collisions we call it as perfectly inelastic collision. Next, one-dimensional elastic collision. If the velocities of the two bodies are in the straight line before and after collision, then the collision is said to be one-dimensional elastic collision. Elastic means both energy and momentum should be conserved. So these are the two types of collisions. In that we have two variants. So you have to write with side headings clearly and you have to explain these collisions. Okay. Next, we are going to the one-dimensional elastic collision. One-dimensional means before collision and after collision they are moving in only one-dimensional. Here, before collision, the situation, this is during collision and this is after collision. Collision mundu, collision tarvata. Here, the two bodies we are considering. The body, first one is M1 and second body is M2. M1 is moving with U1 and M2 is moving with U2. Initial velocities, the corresponding final velocities V1 and V2. Yes, my dear students, here U1 should be greater than U2. So here in front of there is a bike is going with 60, car is coming with 100, then definitely car will cross the bike. Why? Because it has high speed. So that's why then only collision happens. Yes. So in this collision, if you want momentum and kinetic energy, already this, which type of collision? This is elastic collision. So if we consider elastic collision, so what we are taking here? We are considering one-dimensional elastic collision. Okay. Here in this one-dimensional elastic collision, you have to write the side heading elastic. In one-dimensional elastic collision, here kinetic energy is conserved. Kinetic energy is conserved means before collision the momentum is nothing but, so I am writing here momentum formula P is equals to, it is the product of mass into velocity. So whatever that initial velocity or final velocity. Alright. Next, here initial velocity U1, mass M1. The momentum of the first body before collision, that is M1 U1. Next, momentum of the second body before collision M2 U2. Sorry, here m2 and u2, and the momentum before collision is equals to momentum after collision. After collision, what is the momentum? Here m1 v1 plus m2 v2. Momentum before collision, momentum after collision, both are equal. Why? Because the momentum is conserved. In any type of collision, momentum is conserved. Okay. Alright. Here what we are doing now? Just we have to take out the common m1 value. So I am taking m1 common means here m1 u1 is there, here m1 u v1 is there. I am taking transpose this value here. It becomes minus m1 v1 is equals to m1 m2 u2 transpose the other side, that is m2 v2 minus m2 u2. Right. So from this we can take out m1 as common, that is u1 minus v1 is equals to, if you take out m2 as common, this is v2 minus u2. I hope you understood. Just we are transposing this one other side. To take out m1 as common, we are taking m1 v1 terms one side and m2 terms other side. Just this is the one equation. We can take out this as the first equation I am taking, and this I am taking as second equation. Then after, what we have to do? Kinetic energy also conserved. Kinetic energy also conserved. So you have to write clearly kinetic energy also conserved. Why? Because this is elastic collision. So kinetic energy also conserved means the kinetic energy of the first body m1 before collision, that is half into m1 u1 square plus half into m2 u2 square is equals to, after collision, half into m1 v1 square plus half into m2 v2 square. The same thing we have to take out this is m1, right? Okay. So here in both sides, if you take out 1 by 2 common, then 1 by 2 will be cancelled. Then after m1 terms we have to take out common. So m1 u1 square, m1 u1 square. Here 1 by 2 take out common and it will be cancelled. Then m1 u1 square, I am taking m1 v1 square this side, here minus m1 v1 square. So 1 by 2 you take out and cancel it. m1 v1 square I am taking to left side, minus, already this is m2 v2 square minus, here m2 u2 square other side we are transposing m2 u2 square. Okay, I hope you understood. So we have to take out m1 as common here. To take out m1 as common, then what happens? If you take out m1 as common, then we get here u1 square minus v1 square is equals to, if you take out here m2 as common, then we get v2 square minus u2 square. So this is the equation number 3, third equation. First equation momentum equation, second equation after taking out common, next kinetic energy is conserved. So we got this equation 3, right? So now what we have to do here? We have to divide equation 3 with 2. Why? Because here u1 minus v1 is there, here also a square minus b square format, right? So we have to divide these two equations. We divide with the two equations, then what happens? Here I am writing here only, divide equation 3 by 1. Already here there is equation, right? So equation 1 is m1 u1 minus v1. So we are dividing here m2 v2 minus u2, then what happens? m1 cancelled, m1 cancelled, m2 cancelled, but here a minus a square minus b square, a plus b into a minus b, a square minus b square, a plus b into a minus b, so it will be cancelled. Okay, so what we will get next? Only we get here, so here a square minus b square, a square minus b square, right? So after this negative term will be cancelled, only here available only positive term, that is u1 plus v1 is equals to u1 plus v1 is equals to v2 plus u2 only available. So we want to v2, we want to eliminate v2. So here u1 plus v1 transpose u2 this side, then we get v2. Yes students, that v2 value we have to substitute in this first equation or second equation, your wish. So remember, v2 value we have to substitute in this equation, and after that we have to simplify it. Okay, so what is v2 value? Yes, first we will write the equation, then after we substitute v2 value here. Okay, this next slide, right? Here we will see. First, here there is equation m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. v2 value we have to substitute here. m1 u1 plus m2 u2 is equals to m1 v1 plus m2. Instead of v2, we have to substitute that value. What is that value? u1 plus v1. Let us check it. What is that formula? u1 plus v1 minus u2. u1 plus v1 minus u2. This is the v2 value. We have to substitute. Okay. Here m1 u1 plus m2 u2 is equals to m1 v1 plus m2 u1 plus m2 multiply inside m2 v1. I hope you understood. Just to multiply inside, plus into minus, minus m2 into u2. Simply what we have to do here, we have to find v is equal to. To find v is equals to m1 v1 is here, m2 v1 is here. We have to take v1 as common. If you take v1 as common, we get here m1 plus m2. So take out v1 as common. Then remaining terms, so transpose this side. So already, so first we will write this m1 u1. m1 u1 here, m1 u1 here. 1 minute. 1 minute. m1 u1, again u1 term where is here? Here. That's why plus m2 u1 transpose left side minus m2 u1 terms I am writing one side. Next plus m2 u2, a negative m2 u2 transpose LHS, this becomes plus m2 u2. Okay, plus m2 u2, total 4 terms completed. Then remaining, what is there here? m1 v1, m2 v1. You take out v1 as common, we get m1 plus m2 into v1, right? So here we can take out u1 as common, m1 minus m2 by this letter, m1 minus m2 into u1 plus m2 u2 plus m2 u2, 2m2 u2. We can transpose this m1 plus m2 left side, total it divides, okay, it divides the both terms directly. I am writing here m1 plus m2, here also m1 plus m2. So finally we got the expression for the final velocity of the first body, v1 is equals to, okay, right. So if you write this v1 left side, v1 is equals to, we get this expression. Similarly, if you substitute v1 value, same, if you substitute v1 value here, then similarly you get v2 is equals to. How to write this? Denominators sum is constant, but here 2m2, you have to write here 2m1, here cross, m1 minus m2, here write m2 minus m1, into here u1 is there, here u2 write, here u2 is there, here u1 write, denominator sum of masses we can write, sum of masses, all denominators are same, no need to remember. I hope you understood, my dear students, how I am deriving this long question. Okay, right, simply cross. Here subtraction means here difference, subtraction. The 2m2 means here 2m1. Why? Because it is u1 place, that's why you will get 2m1. Here this is u2 place 2m2. This is u1 place, that's why m1 minus m2. This is u2 place m2 minus m1. Right? I hope you understood the long question, 8 marks question. Okay. So one more thing here in this slide. Here see once. If you transpose v1 other side, then what you will get? u1 minus u2 is equals to v2 minus v1. v2 minus v1. Here from this what we can say? Velocity of approach is equals to velocity of separation. Have you understood what is the meaning? For example, the first backside car, it's coming with 100, bike 60, 100, 60, 160. What is relative velocity? Difference in the 160, 100 meter, 100 kilometer per hour, 60 kilometer per hour. Difference how much? 40. Here also, next after collision, the bike is moving with 100 and car is moving with 60. Then here also difference, v2 minus v1, 100 minus v1 how much? 50 only. That's why v2 minus v1, 50. u1 minus u2, 50. So initially before collision u1 is greater, after collision v2 is greater, that's why. So relative velocity of approach is equals to relative velocity of separation. I hope you understood, children. This is a theory question. For understanding, these values are given. Yes, I hope you understood. Thank you. Bye bye. Signing off.